All right, let's talk about something that literally makes the world go round. Gears. Today we're going to dive into the hidden world of these simple machines. Let's jump right in.
Gears are one of those things we see all the time, right? They're in your car, your clock, even your kitchen mixer. But have you ever really stopped to think about how they work? There's some really cool, elegant math hiding inside. And trust me, it's way more interesting than you might think.
So here's what we're going to cover. First, we'll look at their basic movement. Then why bigger gears are actually slower. We'll even do a little bit of math. Don't worry, it's easy. After that, we'll uncover the secret of adding a third gear. And finally, we'll see how this all plays out in the real world.
Okay, first things first. Let's talk about what I like to call the opposite direction dance. This is the simplest, most basic rule of gears, but it's the foundation for everything else we're going to talk about.
So when you have two gears and their teeth lock together, we call that meshing. They start pushing each other. And what happens is, if one gear is spinning clockwise, it actually forces the other one to spin counterclockwise. It's a law of gear physics, pretty much. No exceptions.
Yeah, check this out. It's super simple. They're like a dance partnership of opposites. One goes right, the other has to go left. Clockwise means counterclockwise for its buddy, and the other way around. Easy, right? But hold on, because that's just rule number one.
All right, so we've got the direction down. Now let's add a wrinkle to it. Let's talk about size and what that does to speed.
Okay, quick question for you. Picture a small gear connected to a really big gear. Which one do you think spins faster? The little one or the big one? Just think about it for a second. The answer, well, it all comes down to this cool math idea called inverse proportion. Sounds fancy, but all it means is when one thing goes up, the other thing goes down. So for gears, it's simple. The more teeth a gear has, meaning the bigger it is, the slower it spins. Bigger is slower.
Okay, that's the theory, but let's actually see how this works with some real numbers. We're going to figure out a gear ratio right now.
So look at our setup here. We've got this little purple gear with exactly 6 teeth. And it's connected to a bigger green gear that has 10 teeth. Got it? 6 and 10.
All right, here's the puzzle. If that little 6-tooth gear spins around 5 whole times, how many times do you think the big 10-tooth gear will spin? Let's break it down together.
Okay, step one. Let's figure out how many teeth in total have passed by from that first gear. It's got 6 teeth and it turned 5 times, so 6 times 5 is 30. That means 30 teeth have clicked by. Now, since they're connected, the big green gear also has to have 30 of its teeth click by. So all we got to do is divide those 30 teeth by the 10 teeth it has.
And you get 3. 3 turns. So the little gear spins 5 times, but the big one only manages 3. See? It totally proves our rule. Bigger is slower. That's inverse proportion right there.
Right, so 2 gears? No problem. But what if we throw a wrench in the works, or another gear in the middle? This is often called an idler gear, and it's got a really clever, almost sneaky job to do. Okay, look here. On the left, that's our original setup. 2 gears spinning in opposite directions. Now, look at the one on the right. We've squeezed that little purple gear in the middle. The whole thing has changed. What's the big difference you see? This is the big secret. The first gear makes the middle one spin the opposite way. But then the middle one makes the last one spin the opposite way again. It's like a double negative. So the big takeaway here is that the first gear and the last gear end up spinning in the exact same direction. Cool, right? But wait, what about the speed? Does it mess with our math? And here's the really wild part. No. The middle gear has literally 0 impact on the speed ratio between the first and last gear. You could stick 5 gears in the middle and it wouldn't change a thing. The speed is only about the number of teeth on the very first gear and the very last gear. The middle guy is just there to flip the direction.
So there you have it. We figured out the rules for direction and for speed. Now let's connect all this back to the real world and see where this kind of proportional thinking is hiding in plain sight. Think about your bicycle. When you're going up a steep hill and you shift to an easy gear, you're actually shifting the chain to a bigger gear in the back. Bigger is slower, which means you can pedal faster while the wheel turns slower, giving you more power. The same idea is at work in your car's transmission, in old-school mechanical clocks, giant wind turbines, and yeah, even that mixer you use to make cookies.
So from now on, whenever you see a bunch of gears, doesn't matter if it's in a kid's toy or some giant machine, you'll know what's really going on. You'll see that dance of opposites, and you'll know that it's all controlled by that simple, beautiful math of inverse proportions.
Kind of makes you look at the world differently, doesn't it? It makes you wonder, What other simple things around us are hiding some elegant math, just waiting for us to notice?